Hey everybody, how you doing today? I hope you're having yourself a great Tuesday, and I hope more than anything that you're watching this on Tuesday night or Wednesday morning, so by the time you get to class on Wednesday, you will have already watched this and been like, yeah, I can do this. Anyway, before getting into graphing these more complicated equations, just to review, these are the two different forms of the equation, well, the only form, the form for sine and the form for cosine. But no matter which one you're using, A always stands for amplitude. You can find the period length by going either 360 divided by b or 2 pi divided by b, depending on your degree or radians. The horizontal translation is c. I frequently won't call it the horizontal translation, I'll call it the starting point, because if it horizontally, normally the graph starts at 0, or a period starts at 0, but if it translates over pi over 3, the starting point's now pi over 3, not 0. And then also the D, the vertical translation. This is where the axis goes. The axis is always y equals whatever the D is. And I usually use this, I pretty much always use this 8-step process when solving these problems. I'll first find the starting point using that horizontal translation. I will then find the period length using b, either 360 divided by b or 2 pi divided by b. And then once I have the starting point and the period length, I can build my x-axis. I then figure out the vertical translation d, and I draw it. I draw the axis on my graph immediately. I figure out what the amplitude is. I build my y-axis, adding to the axis and subtracting from the axis for the amplitude. And then I put in the dots, depending if it's sine and it starts at 0, 0, or cosine if it starts at 0, 1. And then lastly, you know it comes last. You sing the song. Alright, so I'm going to use this as a guide to walk me through these problems. Man, this is times like this, I wish I had a second camera so I could get one camera. I could do that, but it would have to be this camera here. Let's see. That's just, I don't know how to do that. Well, I do, but not while I'm taping, not while I'm filming. All right, so here we go. First example. It's got a little of everything. We have 3 times cosine of 4 times x minus 30 degrees plus 5. Start point. The start point in this case, the horizontal translation, the C, is 30 degrees. So I know that the start point is 30 degrees. I could go ahead and build my x-axis and put 30 degrees right in the middle. Next, figured out the period length using B. This one's degrees. So B is equal to 360 degrees divided by, excuse me, the B is 4. So 360 degrees divided by 4 is 90 degrees. So the period length is 90 degrees. So I know that if I start at 30 degrees and I stretch out 90 degrees, I would be at 120 degrees. And if I stretched out 90 degrees in the other direction, it would be negative 60 degrees. And now I finish building the x-axis, doing the midpoints thing, halfway between 30 and 120, that adds up to 150. Divided by 2, you get 75 degrees. These two add up to a negative 30, and if you divide that by 2, you get negative 15 degrees. Yikes, looks like we're going to get some decimals here. Halfway between 75 and 120, that adds up to 195. 195 divided by 2 is 97.5 degrees. Halfway between 30 and 75, those add up to 105 divided by 2 is 52.5 degrees. Halfway between 30 degrees and negative 15, that adds up to 15, which would mean negative positive 7.5 degrees. And then halfway between negative 60 and negative 15, that's add up to negative 75, which means negative 37.5 degrees. Okay, so we have our x-axis. That's got to get through step 3. now the second half of the problem. I always feel like this is half the work, just doing getting that x-axis built. Step 4, the vertical translation. Well, it's at positive 5, and if this is at 0, that means that my axis is going to go here. Uh-oh, Elliot's getting a phone call. Phone call canceled because you guys are my top priority. Okay, let's see. Sorry, where was I? I've got the axis, y equals 5, and maybe I want to write y equals 5 over here. Then find the amplitude. The amplitude is 3. So when I build my y-axis, I personally like to put my y-axis where 0 is. And I'm definitely not starting at 0, so I'm going to do that little thingy there. If I add, well, build the axis. So if 5 is the axis, if I add 3 to it, that would be 8. If I subtract 3 from it, that's going to be 2. So I have my y-axis built. Now, step 7, put in the dots depending if it's sine or cosine. You go to 30 degrees, that was my starting point, and we're dealing with the cosine. This is how Elliot does his cosine graphs. He knows that cosine starts at 0, 1, or up top. And because it starts up top, that means that both endpoints are also going to be up top. And if their endpoints are up top, that means that their midpoints at 15 degrees and 75 degrees would both be at the bottom at 2. And then halfway between the top and the bottom is the middle, the axis. So at negative 37.5 it's on the axis, 7.5 degrees it's on the axis, 52.5 degrees, and 97.5. Now I have the dots, and now I can connect the dots, la 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 la, connect the dots, woo, la 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 la. And I frankly don't think I did a very good cosine graph right here. It's kind of bumpy, but all of the points are accurately labeled with a well-labeled x-axis and y-axis, so anybody could look at this graph and interpret what's going on with it. Elliott graphs are awesome. All right, that was example number 1, doing a cosine graph in degrees. If you have any questions and you're in class, stop the video, ask the questions before moving on to example 2. Example 2, a sine graph in radians. All right. Step 1, find the start point using the horizontal translation C. In this case, we have x plus pi, so the start point is going to be negative pi. So right in the middle of my axis here, I'm going to put a negative pi. The period length is equal to 2 pi, because I'm in radians, divided by, this case, 1/2. How many halves fit into 2? So 4 pi. So if I'm at negative pi and I stretch a distance of 4 pi to get to the end of the cycle, that would be 3 pi. If I stretched 4 pi in the other direction, that would be negative 5 pi. Oh, I like how this one's going to work out. Negative pi plus 3 pi, that adds up to 2 pi. You divide that by 2, you get pi. Halfway between negative 1 pi and negative 5 pi, negative 3 pi. I do the midpoints. Halfway between 1 pi and 3 pi, 2 pi. Halfway between pi and negative pi, 0. Halfway between negative 1 and negative 3 pi's, that is, negative 2 pi. And last over here, negative 4 pi. So that's step 1, 2, and 3. Finding the start point, using the period length to get my endpoints for my periods, and then I build the x-axis using midpoints, adding up, dividing by 2. Okay, now, the axis in this problem is going to be at negative 1. In fact, I'm just going to go ahead and draw my y-axis now. I know this is, I'll put my negative 1 here, and my axis is going to go straight through negative 1. But this case, the amplitude is 2. So it's going to stretch up to positive 1, and down to, if I made this distance a distance of 2, I kind of need to replicate that distance. Let's see, that distance is 2 Elliott knuckles, and if I go 2 Elliott knuckles down, that'd be approximately here. So positive 1, negative 1, that means this would have to be negative 3. Alright, I'm completely built, and I'm doing a sine graph. So I go back to my start point. If you get to this point and you're like, whoa, where's the start point? Maybe you want to circle the start point. If I went back to example 1. Just circling the start point does kind of allow you to easily remember that's the middle point. And we're doing a sine graph, and sine starts its periods off on the axis. So because the period starts on the axis, the endpoints would also be on the axis. Their midpoints would also be on the axis. So at pi and negative 3 pi. So at this point I have 5 dots. They're all on the axis. And then you just got to remember, does sine go up first? Does sine go up first, or does sine go down first? And in that investigation we did, sine goes up first. So at 0, it's going to be a value of 1. At 2 pi, it's going to be a value of negative 3. And periodic, so it goes down, then up, which means over here at negative 2 pi it would go down, and at negative 4 pi it would go up. So we have all these dots, and you know what's next. Connect the dots. La 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 la. Connect the dots. La 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 la. And you have 2 beautiful periods of a sine graph. Alright everybody, that's it. If you can pull off these 2 examples, and these are both everything problems, then you can pull off all these problems. There's a lot of details, but if you follow this process, these always work out great. So on Wednesday, we're going to be practicing these types of graphs, so you want to get good at these transformation graphs, because then on Thursday, instead of just graphing 2 periods, we're going to graph these with a restricted domain. Sounds fun. Anyway, I hope you're having yourselves a great day, and Elliot out. Talk to you soon. Bye-bye.